Okay, so now we're going to be doing 8.4. 8.4, all it is that we're adding inequalities into composite functions. Here's my question. It's an application question. A computer stores the cost, C, for shipping and storing n amount of functions can be modeled by the function given. The store capacity of the store's warehouse is 750 units. So first we're just going to start off with A. Graph this function. And what is the domain? To graph the function, what we're going to do is we're going to move the page down a little bit, and here is our values. Here is our equation. So what we have is a already composite function. So now what we're going to do is we're going to move backward from what we're given, and we're going to break it up into two smaller not composite functions. So we're going to break up these two functions. This is a linear function and this is a rational function. We're going to break them up and we're going to call them f of n and g of n. We're going to use mapping notation, and all we're going to do is we're going to find same point corresponding x coordinates, and we're going to plot them down using the addition in the y coordinates. Here are the mapping notation coordinates. The reason I did not use negative is because this is an application question and you do not need to show negatives for cost or price. So now I've already graphed the function for you, and this is the function. As you can see, it is a decreasing function because of the rational component of it. And you can also see the domain is the only that it stays in the positive. So n has to be greater than 0. From now on, we'll move to B. Now we're going to start on B. B says determine the minimum and maximum of the amount of computers that can be ordered at any time to keep the cost below 1,500, assuming the inventory has the maximum available. Alright, so for B, we know that we have to place an inequality. It's asking us for how much we can ship under $1,500, so I set the function has to be less than 1,500. And this function is equal to what's given here. 1.5n plus 200,000 over n has to be less than 1,500. To solve an inequality, you always have to move everything onto one side. So all I did was I shifted the 15 over onto one side. And now what you have to do is you have to try getting a quadratic equation. To do this, all we have to do is multiply this entire thing by n. If you multiply it by n, you get this as n squared. These n's can cancel out, and this will become a single n. You get 1.5 n squared minus 1,500 n plus 200,000 has to be less than 0. Now we can sub these values into a quadratic formula, which is n is equal to negative 1,500 plus minus square root of negative 1,500 squared minus 1.5 times 200,000, all divided by 2 times 1.5. Once you simplify this, you're going to get 1,500 plus or minus square root of 1,050,000 over 3. When you simplify it, you get this, and once you simplify it even more, you get two values, which is roughly 158 or roughly 842. These values are both of your zeros, and what they state is that you have to have a value in between either 158 or 842. But if we go back and read the question, the warehouse's maximum availability at any given time is 750. So we have to put that into the previous. This means that to earn a profit, or for the profit to be less than 1,500, we have to ship at least 158 to 750 computers at any given point.